You have short notes, long notes, same on the other scale. Yeah, you might not be able to hear, so then you go up with your hand for volume. Now I have actually someone joining in. So actually writing a blog on how engineering concepts like this can be turned into, well, meant to be mental health, well-being. So yeah, it's a bit of an elusive connection. That's what the neural network, the knowledge graph are trying to do. Oh, by the way, I haven't checked if you change the knowledge graph to look like this and then you scroll back to it. Yeah, it goes back to what it was originally. Just saying, we had this music. Yeah, this one, music, EEG to music. So ideally, instead of hands, we want to do the same thing with recording EEG. I actually have some like electrodes and stuff. Have to remove the dust off them. They could record some EEG and then we can convert it to music live. We don't have an option like that yet. We do have a music, Control F, music to, can't spell music. Music, yeah, we do have an EEG to music conversion, but that one is not live, not real time. Do you have methods to represent relation between entities of your knowledge graph? So this was generated by ChatGPT, like all the knowledge graph stuff. The bot just generated the knowledge graph. So they're meant to be, so we have another knowledge graph tool. We have this Graphit tool. So in here you can just paste any text. So for example, yeah, you can take any text. Like there's an example text in it as well, and you can change the number of maximum nodes. This is a text explaining how a cochlear implant works. That's what my PhD was all about. So that text is pretty accurate. I should know if it hallucinated or not. So it did not. Don't remember last time it was like hallucinating on me. As far as I'm concerned, when it's hallucinating, it's actually being creative. But yeah, so you can change the number of nodes. You know, you can start with just 5. So yes, and see what that essentially will give you the title of the text. Yeah, so you can pop any text into this box. It will generate a knowledge graph. So you can make it more as complicated as you like. I think actually untangling it makes you learn what the connections are. So normally, even if you have something crazy like this, yeah, normally depending on the text, there should be like a major node, like this one, patterns, intensity, fire. It doesn't make any sense. Electrodes, yeah, electrode array, electrode mapping, regions. So you can just grab signal. What do we have connected? Yeah, signal, incoming, transmitter, frequency, implant, not sure. Anyway, so then the text, if you're more of a visual person like me, then this should help a lot when reading or writing text. Yeah, I was saying the knowledge graphs are much better than this generic AI generated images, or like at least more useful. Yeah, so this blog is actually comparing, is actually talking about mental health, but I'm not a mental health specialist, I'm an engineer, so I want the blog to be written in engineering terms. So we have, that's why the knowledge graph is there. And we have linked to a knowledge graph tool in the chat alone. Can you explain the following section of the article? Yeah, the structure of it is not great. Okay, we can do a musical break. I don't know if any musicians out there want to try it out and record a video of yourself using it. It's essentially like playing a piano because you have both notes linked to every. If you actually go. Why there? Anyway, you get the idea.
Have you ever wondered if engineering concepts can truly help us understand mental health better, or if we're just scratching the surface? In this article, the idea of using engineering tools like modeling, simulations, and even convolutional neural networks to understand mental health is ambitious and intriguing. But does it really help break down the complexity of the human mind? For example, the use of knowledge graphs to map mental complexity is highlighted as a key approach to visualize relationships between factors like anxiety, sleep quality, and social support. But does having this kind of map actually make it easier to treat these issues, or are we just adding in another layer of abstraction? How effective is it to see anxiety as just a node in a graph? Are there connections we're missing because we focus too much on these visually neat structures? Another thing worth pondering is the practicality of simulations like deep brain stimulation, DBS, modeling, or ERPs for understanding emotional responses. While it's great to see the impact on neural circuits, do these models truly represent the lived experience of people struggling with depression or PTSD? Can a simulation capture the nuance of a person's unique history and mental state? There's also mention of convolutional neural networks being used to identify mental states through EEG spectrograms. It sounds promising, but is machine learning reliable enough for such delicate and individualized matters as mental health? We know CNNs are powerful for image recognition, but when it comes to identifying stress or relaxation, do we risk misinterpretation or oversimplification? I think these questions are essential if we really want to leverage engineering tools for improving mental health. The article also has an active knowledge graph component that aims to help readers visualize these relationships better. But does it genuinely help in understanding, or does it oversimplify what should be deeply nuanced? Take a look at the article and the active knowledge graph yourself. bionichaus.com/mentaleng. I'd love to hear your thoughts. Can these engineering tools truly help us address mental health, or do they risk turning something complex into something too mechanical? All right, folks, we covered a lot today, using engineering tools like knowledge graphs, simulations, and machine learning to explore mental health. We questioned if these tools truly simplify or maybe oversimplify complex human experiences. Remember, there's an active knowledge graph you can explore at bionichaus.com/mentaleng. Thanks for tuning in, and until next time, bye-bye, everyone.